Hello, everybody. So once you've gotten used to radian measures for angles, the other important thing that you need to really have memorized are the coordinates, the xy coordinates of every point around the unit circle. And a lot of people say just memorize these, but I want to emphasize that actually there's not that much to memorize. But first, before we do that, what is the unit circle? The unit circle is the special name for a circle that's centered at 0, 0. So this is actually the coordinate plane. This is like the x-axis and the y-axis here. But the circle whose radius is 1. So like this distance is 1, this distance is 1, that distance is 1. All right, so how would you figure out the xy coordinates of this point up here? So what I want to point out, you knew how to do this last year. Let's call that the unit circle. So here's this point. This angle is going to be pi over 4, otherwise known as 45 degrees. So what's the x-coordinate and the y-coordinate? Well, if we drop a vertical line here, this is the x-coordinate. It's just the so this is 0, 0 in the middle here, the origin. So the x-coordinate is just the horizontal distance to that point. The y-coordinate would be the vertical distance to the point. And this is a right triangle because I've dropped a vertical line and the axis here is horizontal. So like triangle trigonometry is a tool you've already learned that will let you answer this question. So if I want to know, like, so let's think about what is sine of pi over 4. It's going to be opposite, which is this y value, divided by the divided by the hypotenuse. And the hypotenuse here is the same as the radius of the circle. And I've already said the circle is radius 1. So the hypotenuse is just 1. And it's silly to write something divided by 1 because that doesn't change it. So if I reverse the ordering here, I've just got that the y value is sine of pi over 4. By the same reasoning, the x value is just going to be the cosine of pi over 4 because the cosine of an angle would be the adjacent side, x, divided by the hypotenuse. What is sine of pi over 4? Well, so that's something that you evaluate with your calculator. And you'll see that the answer is root 2 over 2. But you should remember it in this form. If you actually type it into your calculator, it will be a decimal expansion. But we don't, in math, we usually don't work with decimal approximations. The true number here is like an infinitely long, non-repeating decimal. And so nobody wants to write that. So it's easier to just write this, which is a completely precise, correct description of the number. Okay, so long story short so far, so this is root 2 over 2. This is also root 2 over 2. So if I was going to ask you what are the coordinates of this point over here, you could set it up as a triangle problem, but you don't really need to because you can use the symmetry of the circle. We know that this horizontal distance here should be the same as that horizontal distance there because this point is just mirrored across the axis. So if this x-coordinate was root 2 over 2, this distance, this horizontal distance here should also be root 2 over 2, except it's a negative x-coordinate. Like this coordinate over here is negative 1, 0. Negative meaning it is in the negative x direction, and I've got a distance of 1. So here it would be negative root 2 over 2, and then the vertical coordinate is still root 2 over 2. So you can fill in right now the rest of these points around the unit circle. But the thing to notice is all of these kind of 45-degree angles are going to have the same magnitude of the coordinates. It's always going to be root 2 over 2. The question is just, is it positive or negative, depending on the direction. If you flip your handout over, you can see all of the coordinates written on the other side here if you want to check yourself. So let's go back and just do one more on the front side again. All right, so here, let's just look at this upper right-hand quadrant 1. This was my best attempt to reproduce it by hand, not very good. But what we're seeing here is we have divided this 45-degree chunk into 3 equally sized slices. So the 45-degree chunk, remember, is pi over 2 radians. That's 90 degrees. So if I divide that into 3 parts, each part is going to be pi over 6 radians, because pi over 2 divided by another 3 is pi over 6. So that's 1 pi over 6. This up here is 2 pi over 6, which simplifies as pi over 3. And then this one would be 3 pi over 6, because it's 1, 2, 3 pi over 6. But 3 pi over 6 is also just pi over 2 because it simplifies. Okay, but same question, what are these xy coordinates? So again, you can set up kind of a triangle trig problem. So I know that the y coordinate here should be the sine of this angle, which is pi over 6. So sine pi over 6. And sine pi over 6 is 1/2. Cosine pi over 6, which is that x coordinate, is root 3 over 2. Okay, so what about these coordinates up here? Again, you could set it up and figure out like cosine of pi over 3, sine of pi over 3. But for memorizing purposes, all you have to do is kind of sketch this little picture and then think, okay, wait a minute. This point is the same as that point reflected across this y equals x diagonal line. So remember, when you reflect something across a diagonal line, that's the same as reversing the xy coordinates. So root 3 over 2, I think about that as being the long distance. Like there's a long distance and a short distance. So if I want to know the coordinate here, there's a long distance and a short distance. And even though my picture is bad, they should be the same. This short distance vertically should be the same as this short distance horizontally because of the symmetry of the reflection. So if this one's y coordinate is 1/2, this one's x coordinate should also be 1/2. And if this one's x coordinate is root 3 over 2, the long distance, this one's y coordinate should be root 3 over 2, the long distance. So that's how you can fill in the rest of the unit circle over here. All of the points here, here, have the same two coordinates, 1/2 and root 3 over 2. But you just have to decide, so like for this one, for example, it looks like the x coordinate is the long distance, but it's in the negative direction. So I know the x coordinate should be negative root 3 over 2, and then the y distance is this short distance, but it's in the positive direction, so it should be positive 1/2. So you can fill in all the rest using just symmetry. So the moral of the story here is there's only really like 4 things that you have to memorize. Here are the 4 things. One thing is you have to know that the full circle is 2 pi radians, because that's how you can reconstruct for yourself what other radian measures are. You have to know that these diagonal coordinates are always root 2 over 2, but maybe positive or maybe negative. And you have to know that for these slices that are multiples of pi over 6, the long distance is root 3 over 2 and the short distance is 1/2, but that might describe an x or a y, or it might be positive or negative. But that's really just 1, 2, 3, 4 things. So if I asked you, for example, what's sine of 5 pi over 4, and you're not looking at this chart up here, hold on. There we go. So we're not looking at the chart. How can you know what sine of 5 pi over 4 is? It's like we've got 5 pi over 4s. And so you're like, what's that? Full circle is 2 pi. Half circle is pi. That's pi over 2. So that's pi over 4. So how many of these quarter slices do we have? We've got 5 of them. So 1, 2, 3, 4, 5. So now I know the point I'm talking about is down here. I know that its coordinates are root 2 over 2, but sine is about the y coordinate, so I know this should be negative root 2 over 2. So even though I didn't memorize the full circle, it took me about 10 seconds to reconstruct that answer based on the couple of things that I did memorize. So your eventual goal, you don't want it to take more than about 10 seconds to come up with these because they're going to be used all the time in calculus. And if it's comfortable, if it's easy for you to memorize things, then by all means, go ahead and memorize. But like I was never very good at memorizing, which is why I liked math, because you don't have to memorize that much. So I just wanted to emphasize you can reconstruct everything just based on a couple of pieces of information.